Okay, we'd like to close off this section with gravity by finding the gravitational field when we are not at sea level on a planet. So up to this point, we've learned about the formula for force gravity. We learned how to get the gravitational field when you're on the surface of a planet. I would now like to have you guys walk through the process of when you are not at sea level, but instead at some altitude. So this applies a lot when we look at satellites, which are pretty high above the Earth's surface. So here we have a satellite that looks like a gummy bear. It is a small satellite that only has a mass of 2.1 kilograms, and it's at an altitude of 100 kilometers. You start by finding your force of gravity, just like you would have done before. You plug in the gravitational constant, 6.673 E negative 11. You put in the mass of the Earth, which you can find on that reference sheet. You plug in the mass of the gummy bear, and this is where things get tricky. The distance is not from the surface, but you have to measure from the center of the planet. So you take the radius of the Earth, and you add to it the altitude. You just have to make sure that you are working in the same units. So your altitude has to be converted to meters before you can plug it in. So if you look, it says the radius of the Earth is 6,378,100 meters. And to that, you have to add another 100 kilometers. Don't add 100 meters. That's not how high up the satellite's going to be. It's 100 kilometers, which is 100,000 meters. So when you add them, you're going to get 6,478,000. Don't forget to square it. And again, for the mass of the Earth, find the value off that reference sheet. And plug in and get your answer. So again, to summarize, when you are not on the surface of the planet, you have to add the altitude in meters to the radius of the planet. If instead of getting gravitational force, you want to get gravitational field, you do the same thing, except just like before, when you're finding the gravitational field, use 1 kilogram as the second mass. Then your answer will come up in newtons per kilogram, which is a measure of the strength of the field. This time we have 100 miles, so you want to make sure you convert the miles to meters. One mile equals 1609 meters. Whatever you get, add it to the radius of the Earth. When you add them together, you then put that in here. Again, use 1 as the mass, and that way you'll get, instead of a force gravity, you'll get the gravitational field strength. At the surface of the Earth, it should be 9.8. As you go higher and higher, that value should get weaker and weaker. All right? If you wanted to find the gravitational field from the sun at the Earth's orbit, instead of using the mass of the Earth, you just use a mass of 1. So, we use our formula, force gravity, Gc, m1, m2, r squared. We use the mass of the sun, but instead of using the mass of the Earth, we do it per kilogram. Okay? We're just using the radius of the Earth's orbit, which would be like 1 point, let's see, Earth's orbit, 1.496 e to the 11th. Use that as your distance from the sun to the earth. But again, instead of using the mass of the earth, just do it per 1 kilogram. All right? That gives you the strength of the sun's field where the earth is located. Finally, we'd like to do it for another planet. So if you're not on Earth, you do the same process we did on Earth, you just use a different planet. So this is the Juno spacecraft that we sent to explore the planet Jupiter. We had it exploring from an orbit around Jupiter, and the closest it ever got to the planet was 559 kilometers. So same as before, we're looking for gravitational field. Mass 2 can be 1 kilogram. Mass 1 should be Jupiter's mass. And the radius that you use should be the radius of Jupiter plus 559,000 meters. Okay? When you get your answer, compare it to the 9.8 that we experience here on Earth. All right, so hopefully you guys understand how to work with objects that are not on the surface, but instead are at some altitude above the object. And again, the main idea is whatever the altitude is, that's measured from the surface, add that to the radius of the planet, and that will get you your distance. So good luck, and if you have any questions, ask me during Macaulay 1.